Welcome back to Let's Go Design, your SOLIDWORKS interactive web series. I'm Jeremy Luchini, and this is episode 6 of the Hot Rod Baby Buggy. Now, last episode we worked on chassis and sheet metal components. We also showed how the design allows the dad to ride along with his kid rather than just push this stroller. We even ran one side of our tracks to test the hub sprocket setup. This episode will go inside those tracks and highlight the suspension movement, as well as showcase the design for the baby seating area. It's also probably a good time to get some answers from a level-headed mom about what we can and can't get away with when it comes to cruising around with a small child. So let's get started. Okay, I'm here with a friend of mine, Sarah. She's also a mother of 2. Thanks for being here.
Thanks for having me. Okay,
Sarah, you know I've been tasked with designing a man-grade baby stroller. I need your help making things safe and comfortable for the baby.
Glad to help. Definitely a good idea to get mom's perspective on this crazy project.
Okay, first question I have is in regards to motion. Clearly, I know babies are comfortable riding in a car, but I'm not building a car, as you can see.
Yes, and babies love cars. They sleep all the time. Mine too sleep all the time in the car.
Probably not going to fall asleep on this. I've got tank tracks on this design. It's going to be more like a roller coaster. They're going to be going all kinds of places.
Oh, well, that might be a little bit too much motion, especially for a small infant who's probably not strong enough. But I would think a 3 or 4-year-old may be okay for that.
Okay, good. So we can still
keep that in mind.
We can take 3 or 4-year-olds, put a harness on them, strap them in. They'll be okay.
Yes.
So the other thing I want to do is add a windshield to the design. It's probably a good idea. We are not strolling, we are driving this thing, so the air coming in could be a problem for the child. What do you think?
I think that's a good idea, especially if you're going to put smaller babies in it, or even the older kids.
That's good, because I want a windshield in the design. It looks cooler with a windshield. It looks more like a vehicle anyway, and it'll end up making the ride comfortable for the babies. So that's good. I think we'll stop there. There's a lot of work still to do. Wish us luck.
Good luck.
All right, cool, thanks.
Thank you.
What Sarah said makes complete sense, but I just wanted to make sure we weren't missing anything obvious. Plus, it's always fun to see the look on someone's face when they see the tank tracks for the first time. I can tell you that she's worried, but she doesn't have to be. I can use SOLIDWORKS Motion on my design to optimize the dimensions and layout of each suspension component to make sure everything is fine. Watch this. Let's take a look at one side of our continuous track suspension. First, the design. Originally, I thought it would be fun to water jet out a selection of bogey wheels with a custom shape, but I decided to buy ready-made hard rubber wheels instead. It saves shop time, saves money, easy decision. Now, these rollers fill up the cavity between each sprocket with an array of wheels along the low track side and a few that touch the top track side to help with tension. The lower wheels are fixed to a carriage plate, and those carriage plates are connected to a pivot arm. Those pivot arms and shocks are connected to a fixed subframe, or what I'm calling long bars. Now, most of this stuff is made of 1/4-inch steel plate, and the guys at the metal shop, they can cut and weld this stuff really quickly, and that's key at this stage and my tight deadline. Plus, the long bar design is laid out in a way that safely handles our fixed shock absorber parameters, like total spring travel distance. Now, on to the analysis. What I can do is create really powerful SOLIDWORKS motion studies, including actual engineering calculations. We can use these tools to determine, for any given load we put on our vehicle, how much this suspension will sag, given the known spring values from the shock manufacturer. To set it up, you can place a reference dimension so we can watch the spring length change in real time, and then at rest position we can create a motion analysis on the overall assembly. We have to add a spring, pick the edges of each perch on that spring, enter the given spring rate, the free length, and if you like, the display options in 3D. Next, we add a linear motor that drives the lower bogey wheel pivot point upward, and finally we click calculate to watch it go. It already knows to use the existing SOLIDWORKS mates for the range of motion. What's interesting here is that these motion studies allow me to figure out where to place the shocks so that with a given weight of the driver, the batteries, everything, we don't bottom out. SOLIDWORKS Motion is so powerful for simulating real-world conditions, and I think our expert mom Sarah would feel good knowing we tested this thing before putting a child inside of it. So now on to the cockpit design you guys voted for. Now, the best approach for us was to keep things simple, but we also wanted it to look cool too. So I went for a window panel canopy layout that resembles an Apache helicopter, but with open sides to allow for the air to flow into the cockpit. Let's take a look. In our prototype, we copied the approach of the helicopters by using a straight line framework. This allows us to use flat plate windows that can easily attach with simple connections. Now, although the windshield design is really simple, the overall assembly is pretty complex. SOLIDWORKS 2012 makes my job much easier here because there's a great new enhancement called Feature Freeze. While I work on the windshield, the computer doesn't have to rebuild the much larger files like the scanned axle and the human figure you've seen us introduce in previous episodes. I still want to see those other components when I design the cockpit, but I don't want to lose valuable time waiting for them to regenerate. The trick with Feature Freeze is just to open up those large part files, set the freeze roll bar where you want, exit back to the assembly, and you'll notice your rebuild times will improve substantially and in turn give you a chance to design faster and with less stress. You gotta love it. I thought you guys would like to see some build progress at this stage. Now I've got both axles mounted to the chassis. They're shortened now, and by doing that, we had to weld the spider gears inside the differential. That way the motor power is driven only to one side. We have more track pieces back as well with the rubber pads you guys voted for to help with traction. The suspension arms are now bolted on, as well as the shocks, the bogie wheel carriage, and the pivot arms. The other thing we're going to do is move the dad inside the vehicle. It's going to help with weight distribution, so he'll be riding on the entire frame and not just the backside. Now the shocks aren't dialed in yet, but you get a sense of the scale of this thing. It's starting to look pretty cool. This is where prototyping really starts to become fun. And now it's time for this episode's vote. As you know, we've been really focused on making this cool for the dad, but the child needs to have some fun too. So let's talk about 2 kid features that you can vote for. Option 1, a device that can blast bubbles in every direction as we cruise along. Bubbles are safe and there's no cleanup. Or option 2, a headset so the kid can communicate all the action from the cockpit back to the dad and really feel like a fighter pilot. Either option works for me, but I'm gonna let you guys vote. That's it for this episode of Let's Go Design. Our next episode will be our grand finale. That's right, it's time to go for a ride. This is what you've all been waiting for, the unveiling of our Hot Rod Baby Buggy. In the meantime, be sure to check out our tips and demos section on the website. Don't forget to vote, and please keep those comments coming on letsgodesign.tv.